Hello and welcome to the Primary Maths Podcast, the show where we talk all things primary maths. I'm Jon Cripwell, and my guest today is a maths teacher with an interesting story to tell. In fact, he's been wonderfully open about the fact that he once feared maths and that his early experiences as both a learner and a teacher left him carrying what he now refers to as maths trauma. But what makes his story remarkable is what came next. A complete transformation in how he sees, understands, and teaches maths. And he now works internationally helping teachers rebuild their relationship with the subject. So you can see why I was so excited to talk to him today. My guest today is Patrick Renouf, and I'm delighted to have him on the show. Welcome, Patrick.
Thank you for having me. It's wonderful to have been invited, and I'm very excited. So,
It's absolutely my pleasure, Patrick. Absolutely my pleasure. So we were just talking, whereabouts in the world are you joining us from?
I'm honoured indeed. I'm joining you from Switzerland, from Zurich is where I live.
Amazing.
So I'm originally from the island of Jersey, and I've taught in Singapore and Zurich, which a lot of people now start to go, wow, there's a lot of tax havens in there.
Okay, well, we'll just put that out there. But
and Jersey is an offshore finance centre. That's important.
Of course. So I mentioned in the introduction that your journey into maths wasn't necessarily smooth sailing. Is it okay just to think back to what maths was like for you at school?
Yeah.
Was it clearly wasn't necessarily your favourite subject?
Well, it was kind of a combination of both, really. School wasn't great, and also home wasn't great. I'm the youngest in my family, and had some quite high achieving siblings who sort of got it. And so I picked up on there was this kind of stress very early on that I was causing frustrations with my level of maths, and that wasn't good. There was sort of the private maths at home, which was very, very stressful. And then there was just kind of like that was extended into its format in school. So in school, I think that like my earliest memories of maths were I enjoyed it. Like we had these workbooks, it was kind of fun. And then when I moved from sort of like infant school to junior school, and this is sort of like a very traditional sort of all boys school that was founded in Victorian times and, all that sort of stuff. Mm-hmm. It kind of left to fend for yourself. I was thinking today sort of in preparation for this, I was thinking I can't really remember being taught maths. I'm sure I have distinct memories of teachers at a board somewhere doing stuff, but the rest of it was pretty much, here's the next page in your book, just keep going.
Yeah, I have similar. I was going to say similar memories, similar lack of memories of much teaching in the sort of late 80s in England. We used to have these ice cream tubs, empty ice cream tubs, sadly. No ice cream in them. But what they were full of was maths cards. And you would go and get your maths card and take it back to your place and sit down and work through the card. Then you'd take your book up to get marked by the teacher and then work on the next card. So I think we'd refer to that as sort of independent learning. I don't remember a great deal of teaching.
It's sort of learning by accident, really. And I remember we used to have these alpha beta books to sort of divide you into sort of the cans and could nots, really. And I really needed a gamma delta,
Yeah.
I remember I'm a little bit older than you, I think. I remember being really excited when they took half pennies out of circulation because I knew those sums would now vanish from my book. Mm-hmm. Then we got these kind of cool sort of more primary ones with cartoons in, and they had an order to them. And I can't remember what the order was, but I just know I was on the green book where other people were on the purple book. I also knew that maths lessons were a really good way to waste time because the teacher would have a cue by their desk. And if you were savvy, you could join the queue, wait till you got close enough and go, go back and then spend the whole lesson doing that.
I completely forgot that I did that, but I also cottoned onto that tactic quite early. I've just remembered I have suddenly a vivid memory that you've awoken in me, Patrick, of standing in the queue for the desk and then getting up to about probably third in the line and going back to work or not
having a
work.
sudden epiphany of like, oh, I
Yeah.
now understand all of multiplication and long division at the same time. I can go back and do it. Oh,
It's,
do you know what? It's gone. I'll go back.
it was that zone of proximal development. That's what it was. I was, as soon as I was in proximal, that zone, I was
Wait,
okay.
was the zone of proximal development 3 children away from the teacher?
I think that's what it must have been. Yeah,
That's what
I
it
think
must
that's
have been.
where it was. Yeah, I never saw that in any textbooks, but
No,
I've come to
Vygotsky
that
got it wrong. You've
realization.
just cracked it right now.
Yeah, yeah, yeah. We'll write a book on it afterwards. Okay, so yeah, what I'm sort of summarising, you were aware that other pupils were possibly being more successful
Yeah.
in lessons than yourself.
And then that sort of happened, and I was kind of aware of that. And then when I got into year 6, we had a teacher with a brilliant name, who I think I can say he's now unfortunately passed away. Wally Lazell was his name. What a great name! He
That
had
is a
slick back
fantastic name.
hair, and he had grown up in Malaya, don't you know? But his way, we would have a Friday test of 20 random maths things, some of which were like, use a compass to draw a pentagon, that I hadn't ever learned how to do.
Yeah,
And then you got the results on the Monday, and if you hadn't passed a certain number, I think it was 15, you had to get more than 15. Then you were in detention on Wednesday doing
oh,
your
wonderful.
corrections, to start it all again on Friday, which was great.
Yes,
So that was a bit tricky. Then I got through into school, into sort of like middle school, and of course they streamed us and setted us, and I
yeah,
went into bottom set and never got out of it. And I don't actually recall other boys moving around in sets either.
right.
So the ones who were at the top probably were terrified of falling into the bottom sets, and the ones at the bottom, we never made it out. You never made it out of bottom set. Um, and I got put on a restricted level GCSE. Like they thought I think they were being kind. They were saying, we're going to get a GCSE. You will get the C if you do this GCSE.
Yeah,
It was like the expectations were set. That's you. And then going to university. I mean, well, I got A levels, 2 years scot-free of mathematics. Amazing. And then going to university and realizing I was having to teach it. But also what was interesting at our university, we went to an excellent one, and I was at Exeter, but they realized there was a problem with all these primary teachers who didn't understand mathematics. And so they kind of had to put all the people doing maths had a million friends all of a sudden, because we needed their help. And then, you know what? They sent us all out into the workforce, still probably just not knowing what we're doing. And then when I started teaching maths, I just didn't understand what it was. I just didn't understand it. And writing on the board in the mornings, I'd write my schedule on the board in the mornings. And when I got to maths, I would feel like a actual physical reaction to writing the word maths. And actually, I nearly failed my NQT year because of my maths teaching. But I'm not going to be the victim. It wasn't my fault, but also like it wasn't my fault. I was doing the best I can. I was using our Abacus textbooks. I was trying everything, and nothing. I just didn't know how to meet the needs of those learners in the same way that I could with reading and writing, and it just became this kind of thing. And then we got this very interesting math scheme called Making Maths Make Sense, by Richard Dunn, which he was amazing. And sadly, he's no longer with us. There seems to be a connection here. I'm not killing you. And his whole math scheme was to do with kids using cups, but everyone did everything at the same time. So I
remember that.
Right?
I hadn't put that together, but yes, that rings a bell.
Excellent stuff with that as well. And it was all kind of concrete, pictorial, abstract, all the things you're meant to be doing. But I never really still got an understanding of what it was. So that's my very long answer. As I was left kind of adrift.
So what changed then? Because otherwise, this is going to be quite a short podcast, I think, Patrick. If that's where the story ended.
I'm still adrift with it. That's it.
Yeah. So what did change? What was the catalyst, do you think?
When I moved to UWC, which is the United World College of Southeast Asia, in Singapore, massive school,
Okay.
very much service-driven school. So everything you do is about service, but it's also they take on all the latest research. And I was lucky enough to. I mean, we had eight classes in a grade. So each grade level is kind of a small primary school. And so I was lucky enough to have a maths coach. Now, every single person in my career up until that point who had come into my classroom had been there in an evaluative kind of
Yeah.
capacity. They were there to judge me. And when Tilson came in, by the way, Tilson Crew, she's amazing. I've got to give her a shout out. I was terrified because I'd got a job at this amazing school, had huge imposter syndrome, and was kept expecting somebody to come into my classroom and go, "There's been a dreadful mistake. We have to send you back home," because you're like, "Oh."
Yeah.
And she was like, "What do you want to work on?" And I was like, "What do you mean?" She said, "I'm not here to evaluate you. What's next?" And I went, I everything basically. And she introduced me to the work of Sherry Parish, who does number talks.
Yeah.
And Sherry Parish's book, I hope nobody from UWC is listening, but one accidentally fell into my bag when I left, and I
These things happen, Patrick. Yeah.
didn't
They do.
find it until I got back home. There has all these number strategies, and so I was suddenly teaching grade 5 maths. And I was doing, and so she helped me to do these number talks, which are kind of these really curated, structured, short 10 minutes strategy talks that help children build up fluency in a strategy. And I worked a lot with her in those, and I began to realize, like, oh, wait, I didn't realize there were all these ways to calculate. I also kind of had this very stark revelation of I didn't really realize that you could kind of take numbers apart to put them back together in like Lego blocks. And I remember one particular lesson, because the whole point is you have the children speak to you and you articulate their thinking on the board so they can see how well they're communicating their ideas. And a child was was telling me their ideas, and I was stopped halfway through. And by the way, most of these sessions I had a bead of sweat coming down my head, because I'm just like,
Yeah.
And the kids were like, "Are you okay, Mr. Renouf?" And I went, "Yes, I'm just learning this with you right now that you can do this with numbers." And then we had an inquiry-based approach. So we didn't have a textbook, we didn't have a scheme. We worked collaboratively to plan using skills and knowledge to plan to conceptual understandings. So we were working towards understandings where we connected ideas together. And it was really fascinating because in order to do that, you have to have a very good understanding of your learning terrain and what your curriculum is.
Yeah.
Because up until that point, I think I had always confabulated my curriculum with the textbook. And your textbook is not actually your curriculum. It's one way to deliver it. And then I began to realize, like, wait, there's all these other ways to do maths. And just learned so much and began to really enjoy it. The big shift happened when Tilson became our vice principal. And my friend Nicole, who was at Nicole, oh my gosh, I've forgotten her. It'll come to me. It'll come to me.
That's okay.
Forgotten her name. Because she was a grade 4 teacher and she became the maths coach. And the school's huge. Like there were 54 teachers you had to take care of as a maths coach. And I remember saying to her, like, "Why on earth would you take that job? Why?" And she went, "Oh my gosh, I used to be the worst math teacher. And working with Tilson made me realize so much. And now I want to help other people. They don't have to worry so much about things." And that admission made me go, "You are very welcome in my classroom." So I spent the next few years working with her. And then one morning briefing, she announced she was leaving. And I just went straight over to her and said, "I'm so sorry you're leaving," gave her a big hug. And then I went, "I want your job." And she went, "What?" I said, "I want your job so badly." It was like this lightning bolt because I'd been on this huge journey and really enjoyed it. And yeah, it really opened doors.
Yeah, that's fantastic. There's a couple of things that you mentioned there, Patrick, that I'll just pick up on for the listeners. So number talks, we had Omar Jennings on the podcast, who's a head teacher of a primary school in London and a big advocate of number talks. And he came on the podcast a few months ago now and talked to us through how his school are utilising Number Talk. So if anybody's interested in finding out more about Number Talks, particularly, certainly go back and have a listen to that episode. And then just recently, I was talking to a, a colleague called Phil Hurd, who works across a trust supporting schools in his trust, the Transform Trust in the East Midlands in England. And he was talking very much as you were saying about the way that education, maths education, primary maths education, really, in England certainly has moved to utilising schemes of work, which are very, on the whole, very well written and very, very useful and very helpful in lots of ways. But what that's done is a little bit like you said with the textbook, sort of put the idea in teachers' heads maybe that this is the curriculum and that the next step in the scheme is the next step that we need to take, and actually we need to perhaps be a little bit more critical and think about the pupils in front of us right now, and what is the next step actually, is what's coming next actually the right thing for them, and it sounds like that was sort of the approach that you had in your school as well.
Yeah, it really was. And to be honest, at my school in Jersey, we were actually free to do a lot of stuff, but I think my confidence didn't help.
Yeah.
Um, and just a word about schemes as well. Like, they're really good. Well, first of all, a scheme is only as good as the person delivering it and how you use it. It's a tool, and so is a hammer, but I'm not using that for every job.
No.
And I think schemes are very good if you want to cover everything. Now, I'm a concept-based inquiry trainer, so this is kind of my thing, my jam. So I'm very much into the work of Lois Lanning and Lynn Erickson. That have been taken on by Carla Marshall and Rachel French, their work, and they're sort of about bringing in concept-based inquiry into classrooms.
And we'll dig into that in a moment, if that's okay, just to really understand what that is.
That's but they have a phrase that when we're covering the curriculum, what happens is you get quite two-dimensional learning because it's an inch deep but a mile wide. And I feel like sometimes with schemes, that's what we do. We cover everything, but we never get that depth. And it's kind of about I feel like what I've learned to do now is cover everything, using that word, but also find the opportunities to bring it together, to go, okay, these all bits come together here. And the children move the children's thinking to a conceptual level, which means deeper learning. And also they file it away in their heads better, and it's better for retrieval. It's impossible to condense and compress processes, but it is possible to file them conceptually, if you know what I mean. So it's better for retrieval. I often think of it like a game of Tetris. Like that's how maths was to me. These blocks were coming down and the music was getting faster and I wasn't clearing any lines.
Yeah.
If we teach conceptually and if we kind of give opportunities for children to file their thinking, we're clearing the lines and leaving space for more blocks to come down, even if the music gets faster.
And that's interesting. I think just to give perhaps an example of what you're talking about, but correct me if I'm wrong. I was working with some ITT students a couple of weeks ago, and we were looking at multiplication. We had a whole day, Patrick, on multiplication and division. The lucky students, and we were talking about procedures, and the curriculum in England says that we've got to teach formal written methods, which I'm not against in principle, but it's how you get there, which I think is really important. But the idea of the conceptual understanding is so important with everything, but in terms of multiplicative relationships, for when you come to something like a quarter times 3, and I've given this example recently on the podcast, so listeners might be familiar, but a quarter times 3, you might look at that and say, well, I don't know what to do with that. But if you have a conceptual understanding of what multiplying by 3 means, then actually you can see that additive relationship as well, that it's just, a quarter plus a quarter plus a quarter. It's 3 lots of a quarter. So you can, correct me if I'm wrong in what you're saying, but I think you're saying that the procedure is important, knowing how to do that is important, but
Absolutely.
the conceptual understanding of, what method do I use? Well, actually, it's really clear what I need to do if
Yeah.
I understand deeply what it's asking me to do. Is that right?
Yeah, yeah, it is. And also it's reading for meaning. Like if I looked at 1/3 times 3, I would just read it as a third of 3. I would
Yes.
just take that of
Yeah.
and be like, ah. But it's through modeling. Like I learned so much about modeling that kind of multiplicative relationship. And actually, if you model multiplication of fractions, you understand why you get a smaller product.
Yes.
But also, it's kind of when we're doing concept-based inquiry, it's about allowing children, inviting children in. So we use a word inductive learning. So a lot of what I've experienced growing up, and indeed a lot of my early teaching, was deductive teaching. I present a learning intention to the class, which is a truth, to quote Jane Austen, a truth universally acknowledged. Okay. And then I give them examples of that thing I've told them about. And then at the end, they go, oh, yeah. Whereas with concept based inquiry, I will invite them in with questions. Like questions I've thought about, not just random questions like, so a good way to start that is try flipping your lesson intention, your learning objective into a question. So you're not
Okay.
giving away the end of the movie. And then I invite the children to explore patterns between things, like what happens when we multiply this? What happens here? What's happening here? What's happening here? What do you notice? And they start to look for connections between those case studies. And that could be an equation. It could be a 3-word problems. How are these word problems all the same? What are they requiring you to do? And the kids kind of take a step back, and all of a sudden the focus is not like, I've just got to answer it. The focus is, wait, what is this asking me to do? And how are these the same? How are they different? And when you put that angle on it, now they're starting to think like mathematicians, because mathematicians are looking for regularity expressed across multiple things, case
Yeah.
studies.
Yeah.
They're looking for that justification. They're looking for that proof. So answering it is one part of it. Answering it correctly is even better. But if they can explain why it works, and, I sort of think that's, for example, subtraction is really interesting because subtraction is so many different things. And I think that's why children kind of struggle with it, because addition sort of, okay, I'm putting stuff together, but subtraction is comparison. It's more than, it's less than. It's also addition in disguise. It's also all these different things. So if we invite them to explore subtraction in all these ways and they start to build up this understanding, they're like, oh, wait, they're bringing those connections together. They can start to then go, so does that mean this? And then they start to generalize. And when they generalize, they're basically stating to you their own version of what your lesson objective kind of was. So that's what we call inductive learning. They are allowed to watch the movie and give you their ending. Whereas deductive learning is, I've already told you the end of the movie and now you're just going to watch it anyway. So I find inductively, like if I craft it so that I ask them questions, present them with case studies and ask them, how are they the same? The engagement is higher. They're looking, they're questioning, they're engaged. And then they feel like they own the maths that you have just taken them through, but they don't need to know that. I mean, I always try and think of my children as like, I did a lot of amateur dramatics. I tried to think of them as like a Saturday matinee audience. They don't know what's meant to be going on. Let them enjoy the performance as well.
Yeah, no, that makes a lot of sense, and I think sort of reflects part of the journey that maybe, again, England has been on in terms of a teaching for mastery sort of approach based upon a lot of Singaporean and Shanghai type teaching practices. But just can you define, you've mentioned concept-based inquiry several times, and obviously that's your area of expertise. Can you sort of define that for us, just so that we're really clear on what you mean by that?
Yeah, and it's something that can be applied to all areas of the curriculum, everything. It's for everything. It's not just maths. So it is basically, yes, it is through using guiding questions and specifically chosen case studies. You invite children to look for patterns and make connections between concepts. And when they make connections between those concepts, they've made a generalization. And that's kind of helping them. That's mirroring how our brains operate and file the information we take from the world around them. And it makes their learning transferable.
So
You
that sort of
use
generalization is I've noticed that this happen. I've noticed when I add two even numbers together, the sum seems to be an even number. I wonder if that's always true.
exactly.
That would be a
So
sort of
they are
generalization that you've noticed.
that would be a generalization probably for one of the earlier years. Absolutely. And the another generalization for an upper year might be when multiplying fractions, the product is less than, one, whatever it is, if you depending on
Yeah,
what you're doing. That would be it. And so you want them to get that, them to state that in their own words. And I never show them my objective. Like the lesson objectives are my questions. This is the question we're working on today. And then I get them to actually write them down. And it really transforms how children partake in maths. So, for example, I'm working a lot on the concept-based inquiry maths, CBIM. So you can look that up. It's a full scheme. I'm sort of not selling it, but it's also, that's kind of where I've been working. And basically, when I was doing that in my class full time, I really noticed the playing field level out. So I noticed that those children who see themselves as confident mathematicians, but are in fact very good calculators,
yeah,
start to kind of, one of them came up to me and he went, at one point, he went, I have never had to think about maths in this way before. And I was like, good, because now you are experiencing what every other child in this class is experiencing, right? And you're having to think. And now, if that sounds quite vindictive, but it
no,
was.
but do you know, I was having a conversation with Becky, who is my co-host on the Friday editions of the podcast. We sort of call that the aftermaths, and there'll be one for this episode where we'll discuss the interview. And we were talking today actually about the importance of. We often say what qualities do we want mathematicians to have? And generally, one of them is resilience. We want them to be resilient and not give up easily. And to do that, you have to experience a little bit of struggle, don't you, at some point? Otherwise, you're never going to be resilient because you haven't practiced that skill. So there does need to be, doesn't there, an element of challenge? Hopefully, not too much that we just stay stuck forever, and that's the expertise, isn't it, of the teacher in pitching it
Well,
correctly.
this
But
is right. We want productive struggle. We want grapple.
yeah,
And
yeah,
he was experiencing that. And that meant I was meeting his needs. What I also found in my concept based classroom is those children who didn't see themselves as mathematicians started asking questions. So whenever a child asked me a question about maths, I go, that's exactly the kind of question a mathematician would ask. And they look at me and I go, because at some point in human history, somebody asked that question, which is why we are doing this maths.
yeah,
Every single thing that happens in maths was invented by humans to help our world, not
yeah,
to torture children. And this is the kind of thing. So I notice the playing field levels out. I notice, and just generally from my experience, I've noticed through concept-based inquiry, the girls in the class tend to find they have more of a voice because it's about thinking, reflecting, connecting. The boys tend to start to have to think differently. And I hate saying that's the boys and the girls, but a lot of the time by grade 5, already you see this dichotomy and I
yeah,
hate it. I find the boys having to take a step back and go, wait, he's not just happy with an answer here. There's got to be more. And so it kind of really it sort of evens that playing field. On top of that, talking about what you were mentioning, I'm sure you know James Nottingham's The Learning Pit,
yeah,
which is my absolute favorite thing. I use it all the time. And it's, I get the kids to draw it out. And I often say to them at the beginning of a lesson, guys, look, folks, we're going in the pit today. All right. And they're like, almost like they're rolling up their sleeves. They're like, fine, bring it on. Let's get in the pit. And there's sometimes kids will come to me and be like, right, I'm in the pit. And I was like, okay, what do you need? Because what happens is if you look at the learning pit, children get to you sort of look in, you think, hey, I can do this. And then you go and you go, wait, this is harder than I thought. And at the bottom, they're kind of like, I'm confused. Now, what I've done in my teaching career is when kids are confused, like one of those claws at the arcade, I come down and then I pick them up out of the learning pit. But very rarely do I put them at the other end where success is. I bring them back to the beginning. If you take them out of the pit, you just end up putting them back at the beginning. They haven't learned anything. So through the work of Jo Bola as well and her mindset messaging and stuff like that, you can really affect positive change when children realize, wait, learning's meant to be tricky. And you're like, yes. And we also know that we say to kids, if people are going like, hey, that was easy, I've got it. That learning can be easy come, easy go.
And I think in maths particularly, sometimes as teachers, we can get, and certainly early in my career, we can get very hung up on the answer being the most important thing and the thing that we reward and value more than anything else.
And we've talked about them too.
Yes, yeah. And we've talked quite a lot on the podcast really about how we can shift that mindset in teachers, that actually the answer is important ultimately in maths. It is kind of what we're going after, but it's possibly not the most important thing. The most important thing is what we notice along the way and the connections that we make and the way that we're challenging our thinking a little bit. And if we can reward children more for those things, even if they're not successful in inverted commas in finding the solution first time round, then we're going to build more confident mathematicians, aren't we?
Yeah. And I absolutely agree with you on that. And you just, while you were saying that, it made me realize my favorite word that I use in class is conjecture.
Yeah.
So I just sort of say, whenever we're kind of doing a shared bit and people are sort of throwing out answers, we're like, well, it's a conjecture, because we don't have the proof for it yet. So it's what you think it might be. And I like to put them all up on the board, all of them, or even, whatever, some of them are like far off the mark, they go up.
Yeah.
And what we then talk about it. And then sort of those children who realize they're far off the mark, they're like, wait, I see where I've gone wrong. And they get a chance to do it. And I also like to use the word conjecture because Tilson, who I told you about, my math coach, she was doing a number talk with my class and she kept saying, she was American. She was like, conjecture, conjecture. And this kid kept shouting out. And you could see it was starting to bother her as it kept happening. And eventually, after this, she said, why do you keep shouting out? And he went, my name's Jack. And she went, uh-huh. And he went, you keep saying, can Jack share? And then you tell me off for sharing. So she was going, conjecture. And he was like, 12.
Yeah, Jack can share. Yeah, absolutely. Yeah. Yeah. Well, I said at the start of the interview, you might be our first international guest. I was completely wrong, I realised, because my very first guest on the podcast was the wonderful Heidi Kirkland, who teaches currently in Malaysia and does a lot of work on maths anxiety. And I wrote a book on it recently, and I've also spoken to her colleague Tom Hunt, who's at the University of Derby, who also does some work on maths anxiety. So we've got some ideas of on the podcast of what maths anxiety might be. But in your experience, Patrick, what do you think the main causes of maths anxiety might be, to help us to sort of understand how schools can shift the culture so that we're not encouraging that, we're trying to negate it?
Sorry, I've got about 500 ideas going around in my head. My main mantra is maths is about thinking, not performing. And I think that's the antidote. So if we have a performance-based classroom where things are high stakes, that's where it starts to happen. Just valuing the fastest answer first, fastest finger first, already children start to just disengage with maths. My main fear, I touched on it at the beginning. I remember on Sunday evenings, the family would be in the living room watching Sunday evening telly, and I would be in the kitchen writing out my times tables, just writing them out. And it was just not helping, and reciting, rote learning, like in the car on the way to school in the morning, mum would be like, right, times tables, off you go. And it was like, this isn't meaningful, because
Mhm.
to me, it became like the alphabet.
Yeah.
So I, for example, I find it very difficult when someone says to me, K, what letter of the alphabet is that? What number is it? I have to start the alphabet at the beginning and work my way through.
Yeah. Yeah. Absolutely.
Because it's just, I can't jump in and out of the alphabet. I've just never mastered that. And that's what times tables were like. So if I needed to know six sevens, I got to start at 1 times 6 and just go through the song. That is not that, and that starts to make you anxious, because that works for a bit. And I think maths anxiety is when you realize that the stuff you have to rely on is no longer working, and you don't know what to do because everybody else has got it.
Yeah.
There's been some research recently. I have the book down here, because the person who's done the research has got a really long last name and I can't remember, but I should get it out for you in a second. And she was saying that, especially in maths, so when your neural pathways form, because maths is hierarchical, if we don't get those foundational neural pathways to start with, and then you have to myelinate them, so that's your deliberate practice and fluency.
Yeah.
If we don't have those, then it's impossible to make the other connections afterwards. And that's what happened to me. I was building bridges without any foundation. I didn't know what that was. And all those sort of things, if we're not making sure that it's solid to begin with, that all leads to anxiety later. And that's when coping strategies start coming in. People they line up at the teacher's desk and then wander off. They go to the toilet, all those avoidance things. I think I've answered your question in a very roundabout way.
No, no, no. I totally, I completely see what you mean, Patrick, and it's sort of everything that we've been saying, isn't it? That
Yeah.
maths can be presented sometimes as a feat of memory and a list of processes and procedures and facts to be remembered, whereas actually maths isn't that at all. And the beauty, as you've said elsewhere, the beauty is in the connectedness of maths and the way that it gives you the skills, I think, to work out, to try and work out what to do when you don't know what to do. That's how I see maths. It's a method of problem solving, and that can apply to the maths itself, can't it?
Yeah.
So for me, I had real problems with learning times tables, uh, and looking back, I just didn't know what it meant. There were these numbers that two of these numbers together gave me another number, and if I could remember the combination of those, then I knew my times tables, but I didn't see the purpose for them
Yeah.
at all. And so it took me a long while to work out that if I knew 6 times 6, for some reason I can remember square numbers more easily than I could other ones, but if I knew 6 times 6, then I could work out 6 times 7. It took me a long time to realize that, because I didn't see any connection between 6 times 6 and 6 times 7,
Well,
really.
nobody
Um,
taught us strategies around those things.
mm,
There was only one way to do it, and that was the algorithm. And
that's right.
that it didn't apply to anything else. And I didn't really understand how division and multiplication were linked, because it was like, it was meaningless. It was just meaningless. You're absolutely right. And then when they brought in fractions, and I was like, wait, how's that linked to multiplication?
I definitely left secondary school having not a clue about fractions and teaching. So my first teaching post was in year 5, and the next year I followed that class into year 6, and I had to teach them fractions. And I have to hold my hands up. I think I taught them very badly
Yeah.
in the first few years, because I had no conceptual understanding of what a fraction was.
Mm.
Um, and yet now I understand fractions, you know, I don't want to blow my own trumpet, but I think I've got a good understanding of what a fraction is. And I've got 2 daughters, Patrick. 12 going on 13 in year 8, and one who's 7. And last night we were cutting a pizza up, as you do, and I cut it into 6 pieces. Obviously, they were not equal pieces, but let's pretend they were. And I said to my daughter, uh, I've cut this into 6 pieces. What have I got? And she said 6 quarters. And I thought, oh yeah, okay. So we've got this idea that a quarter is less than a whole, but not really what a quarter means. So there was an opportunity to talk about that. You can imagine she was delighted. But it's that sort of understanding or lack of, those opportunities really to understand what a sixth is and what a quarter is, and the different, what's the same and what's different, as you said before, that help to make the connections, isn't it, between
It
actually the
is.
conceptual understanding and what it looks like.
And also, like, this is also my other thing as well, because I now, my passion, I love education. I love teaching maths with kids. I love it all. But my real passion is helping teachers to understand it. And I now look at my teachers from when I was at primary school, and they were just doing what they knew. Like, God
Yeah,
knows what maths was like when they were at school. Like, and they probably were just doing the best they could with what they had, but they didn't know, and they didn't understand how to use manipulatives. And I kind of see it all the time that I think teachers are just falling back on what they have, their experiences, and they can only bring those. And I just want to help them, because I went round. So I've been, I've worked in schools before, and I'm just kind of like trying to find the base 10 equipment, and you find it, and it's at the back of a cupboard, and it's got a layer of dust, and it was like, and I explained to people, I said, you can use base 10 equipment to teach decimals. And when I show them how, they sit there kind of going, you can't, that, yeah, I can do hundreds and thousands with this. And you're like, yeah, you can.
yeah, yeah, absolutely.
You can use manipulatives all the way through to, year 13, if you wish.
You
Um,
just have to reframe what the whole is, and what the
yeah,
1,000 block stands for, and you've got it, haven't you?
exactly. And
Um,
it's just, I think we've got, it's not so, we've got two problems going on in the world. One is we've got math anxiety in children, but one is we've got math anxiety in teachers who have probably joined the teaching profession like I did, because you like learning, you want to do some great stuff, to get a love of reading, have cool stuff, do all the stuff that's wonderful. But when it gets to maths, you're kind of like, well, if that doesn't happen today, I'll be happy to do something else.
yeah.
Um, and I just wonder how many of us are out there every day just faking it and hoping nobody finds out.
And
Um,
time is getting on, and I do want to talk about the work that you do in that domain. But I did think it was funny, because we know that education is sort of cyclical in nature, cyclical in nature. And again, I was working with the students a couple of weeks ago on multiplication, and I was showing them the long multiplication procedure, column procedure. And they were sort of saying, well, this wasn't how I was shown it at school. At school we did the grid method, and, can't we just do that? And it just made me think, when I was teaching the grid method at school, I had parents saying, well, this wasn't how we were taught it at school. We did the long multiplication method. And it just, it always feels like teachers are trying to catch up with, this wasn't how it was taught at school. I've got to teach it a different way now. So how can we empower teachers to feel more confident about things that they just are not within their knowledge at the moment, without having a Tilson to come in and sort of work with them on a daily or weekly basis?
yeah. Yeah, good PD. But also, like, this whole thing of that's not how I was taught it. It's like, okay, there are so many ways. I can't remember actually the last time I did the long, or taught the long method for multiplication. I actually cannot tell you, because I just know of, like, partial products is so useful. And
Yeah,
and I think that's what going back to Sherry Parrish's number talks, we've got all these strategies because we're building accurate, flexible, efficient mathematicians. That's the three words we want out of everything. And children, if we give them all these strategies, okay, there might be the odd child, you just give them one or two strategies, they can go. But the more strategies children have, and the more they realize when is best to use them, we're going to lose that thing of that's not how I was taught it, because so many ways. And also, in my head, a voice is shouting, invented strategies. Let children invent their own strategies. Maths was created by people who solve problems. Let children create their own maths. If they have a way of doing it, brilliant. Let them do it that way. If it's not efficient, they'll figure it out. Show them the next one, but let them have their own maths as well, and they can do that. I just think there's so many ways to do it, and I'm in this kind of like funny relationship with the sort of like the algorithm, the formal algorithm. So I went to a Jo Boaler course because I fangirled when I met her. And she's currently talking, her latest book is called Ish, and it's about number sense. The key indicator of a child's success in mathematics is their number sense. That is the one thing that all top mathematicians have, is a very good sense of numbers. What they're finding is that when children are introduced to the formal algorithm, it kills number sense dead pretty much, because a lot of children stop thinking about whether that's, and that's when we get that problem of, when you say, hey, make an estimation before you solve it, 95% of children in the class will solve it, then give you a wrong answer as an estimation. And that shows they're not thinking about the numbers. So it's that. Sorry, I'm rambling and passionate.
No, you're not. And I think it's a really good point. And for anybody who's not aware, number sense is sort of that understanding, that intrinsic understanding of what 5 is and what it means, and the different ways that you can pull 5 apart. And, you can do it with 5 and 0 is 5, but also 3 and 2 is 5. And if I put 2 5s together, I've got 10. And that sort of idea intrinsically, isn't it, that we understand what number looks like. But I do agree. In England, we have a curriculum that says we've got to teach the formal, efficient written methods. But I think what we sometimes fall into a trap of is teaching them far too early, and as you say, not spending enough time exploring all the different ways. So regular listeners will smile at this because they know I'm going to go on about division again. But I had constant, almost as a maths lead in a primary school, every year at a certain time of the year, I knew that I'd be having a conversation with the year 4 team, who were brilliant and who, just wanted the children to be successful. But they would say, why are we teaching division in this way? Because what I wanted them to do was to look at how we could partition the numbers, break it apart, do repeated subtract, all of the sort of things that don't necessarily give you an answer to a division question very quickly, but are really, really important to understanding what's happening with division when you're doing it. And they were saying, we could just show them a short method and they get the answer. And it goes back to, again, what we were saying earlier, that the answer is not really what we're interested in at this point. I know that if you do all of this work now, when they come to me in year 6, I'm going to be able to show them an algorithm and they'll understand actually what's happening in there. Yeah. And if they can then decide, I want to use this method today because actually these numbers really lend themselves to this method, or I'm going to use a mental method because these numbers lend themselves. But what we want them to do is look at the numbers in the first place, and as you were saying earlier, Patrick, think first before just going to a procedure. And so, sorry, I'm going on a rant now, but it's good. I completely agree with you in so much as, we rush towards these procedures because we think it's going to make the children's lives easier, but actually in the long run it has the opposite effect.
Because then we start to teach tricks like, there's a magic 0, or we borrow from there's so much in them that's just a mystery, and it's not a mystery, but to the children it feels like it is. And just to add on to the point about getting an answer, there's one thing that Jo Boaler wrote that has always stuck with me, that if a child brings you, like, if, you've made them do a page of sums, which I now know do, like, first of all, if a child can do the operation 5 times, they know it.
Yeah.
If they can't do it 5 times, they don't. Don't make them do 20 or 30 sums, just don't.
Yeah.
But for example, if they do and they come and they're all right, she always says to the kids, I'm so sorry you didn't learn anything today.
Mm-hmm.
Because if a child has got everything right, they're only showing you what they already know. And our job as a teacher is to find that next learning pit where they're in. So I think it's quite nice because those kids are like, oh, I got everything right. It's like, okay, but you didn't learn anything.
Yeah.
And I think that's quite a nice message to go, okay, I've got this. What's next? Like, you're not a finished product. And it's that resilience as well. I think that's
Yeah.
a really important message.
I think for context, and I do agree that there should be an element of, as we said earlier, a little bit of struggle. And but I would occasionally challenge as a maths lead, somebody looking in the books and saying, well, all of this work is right, that they haven't learnt anything. Within the way that we used to teach, there would only be a little bit of independent practice at the end of the lesson, really. There'd be a lot of work on whiteboards and other things going on in the lesson. And so, maybe we just need to be a little bit careful that actually maybe they couldn't do that at the start, but they've learned through the lesson and now they've put it into practice at the end. But I do agree, if you could do this at the start of the lesson, and you can do it at the end of the lesson, you haven't learned anything along the way, have you?
And there is also as well, like, there is important to build fluency, and we do that, but also fluency can be built through all sorts of games and not just pages of sums, right? That's
absolutely
as well. Like, it's not kill and drill, right? So you're not gonna drill and kill. You don't drill them to kill the joy. Like, I
was talking to Rob Easterway last week, and he was talking about using sort of maths magic. As is, I can think of a number and I'll know what your number. Sorry, you can think of a number and I'll predict what your number is, as a way of practicing fluency, and then deconstructing that to see why that method works as as an inquiry based sort of model. And I thought, that's a really nice way of sort of practicing a little bit of fluency, and then thinking, well, why does that happen? How have we done that, and pulling it apart.
And that's what we want them to ask. We want to ask why, right?
Yes, curiosity. That's one of the other traits that we often talk about good mathematicians having. We want children to be good mathematicians. We want them to be resilient and problem solvers and be curious. But I'm not sure how often our lessons set us up to be successful in that.
And it depends how you test their resilience, right?
Exactly. Yeah, exactly. Patrick, we've covered an awful lot, and I'm conscious of taking up your evening there in Zurich. And I think there's probably more that we could talk about on a follow-up conversation at some point, which I would love
nice
to
you
have.
want me back. That's lovely.
Oh, no, absolutely. No, it's been great. Lots to think about. If people want to find out a little bit more about your work and the services that you offer and things, I know, as you say, you do work with teachers who might feel less confident or just want to improve their teaching of maths. Where's the best place to find out more?
Well, I'm on LinkedIn, so you can just put Patrick Renouf in, and there are very few of us, which is quite nice. And then also I have a website. I have a website. It's patrickrenouf.com. It's very, very straightforward. And there you sort of get in touch.
And just because you're in Zurich doesn't mean that you wouldn't be supporting teachers elsewhere in the world.
I live 6 minutes from the international airport, and I'm very happy. So I've worked at schools in Denmark and Germany and all sorts of places. So very
wonderful.
happy to come and be.
Wonderful. Thank you very much. Thank you again for your time this evening. For the listeners, if you've got any questions that you would like me to send over to Patrick on your behalf, feel free, or anything that you'd like myself and Becky to discuss on Friday's episode, just send me an email, primarymathspodcast@twinkle.co.uk, or find me on any of the social media platforms and leave me a message on there. I'll be back with Becky on Friday for another Aftermaths episode. If you haven't already, I'd really appreciate sorry, I'll edit that and start that again. If you haven't already, I'd, as always, appreciate just hitting that subscribe button, or sharing this with a colleague who might find it helpful. In the meantime, I hope everybody has a great week, and we'll see you again on Friday.